Hi, hello friends. I hope you all can hear me. So let us continue the electrical machines quick revision session. So till the last class, we have been completed induction machine, not induction machine fully not completed, but transformer we were fully completed, and we were also completed synchronous machine. Now we are in induction machine. In induction machine, already we were completed the basics of induction machine, and we saw the power equations, and we saw how to bring the relations between copper loss, mechanical power, and output power at all. So from this, let us continue from this scratch. If you observe, so these things we have already covered in the last class itself. So let us continue from here. But prior to that, see there. In the last class, I have been completed up to this point. We were discussed about air gap power and the copper loss, mechanical power, everything we were completed. Now let us complete. So entire analysis we know. From here, let me complete the rotor power flow equation. See, what we have to understand here is when the moment we are talking about the induction machine, it is very important to know about the power flow equation, because most of the time our attention with the efficiency calculations and the air gap power calculation, mechanical power calculations, output power calculations, copper loss. How can we do this? Power flow equation of induction motor. If we talk about the power flow equation of the induction motor, for motor we know we are giving electrical power as the input power. So for an example, if I am giving the input power on the shaft side, that is on the stator side, I am giving this is the input power. Now we know on the stator we have three-phase balanced winding. So that winding actually we have wound that winding on the ferromagnetic material. So on the stator, from the ferromagnetic material we can observe some losses, that is called electrical constant losses. Of course we can call these constant losses as iron loss. Iron loss equal to copper loss plus hysteresis loss. So that is the first loss that we are observing from the iron magnetic material, that is ferromagnetic material that has been placed on the stator side. So this is the addition of hysteresis plus eddy current loss. The second loss is on the stator we also wound our copper winding. So this copper winding is giving one more loss that we are simply calling it as copper loss. So totally we are having two types of losses. One is variable loss, another one is constant loss. All put together we are having two losses on the stator side. Now from this total input power, some amount of power has been wasted as the losses. Rest of power will be entered into the air gap, that is called air gap power. This air gap power can be calculated in two ways. One is if you are aware of the amount of voltage that is enter into the rotor, I can call it as EL or E2. We are usually using the term is called E2, that is amount of voltage that is being generated on the air gap side, E2, and the current that is being injected on the rotor side into power factor angle between them. So by using this formula you can calculate the air gap power. This is line voltage, line current, and power factor among them. Suppose if you are having per phase voltage, per phase current, then the formula will become 3 times of induced voltage per phase into induced current per phase into cosine of power angle, that is power factor angle between the voltage and the current. Now there is one more formula to calculate the air gap power. The another formula that we have already observed, that is rotor current I2 square into R2 by slip S. So this is the alternative formula, but this is the per phase power. See, this is the per phase power. To know the total power, you have to sorry, you have to multiply it by 3, such that it will be giving the total air gap power that is being generated between the stator and the rotor. Now from this air gap power on the rotor, once again we will have rotor copper loss. So this rotor copper loss can be written as I2 square into R2 per phase. For 3 phase, you will have to multiply it by 3. Whatever the term that I am considering, all are per phase parameter. So if you want to know the total power, total loss, then multiply it by 3. Now, what I have to do, see there. Total input power from the stator. We observed some losses in the stator. I have subtracted them. Then we got the air gap power. From the air gap power, we have to subtract the rotor copper loss. Then you will be getting the mechanically developed power. From this mechanical developed power on the rotor side, what will happen is once this mechanical power is developed, then immediately we will be facing two more losses. they are called friction and windage losses. So they are also called constant loss, but they are mechanical constant losses. We already observed that on the ferromagnetic material we have already iron loss. That is also called fixed loss or constant loss. On the mechanical side, once again, there also we have some constant losses. They are called friction and windage losses. If mechanical losses will be given, that is friction and windage losses will be given, then you have to subtract these mechanical losses from the mechanically developed power, such that the overall output power or shaft power is going to be equal to mechanically developed power minus mechanical losses. Mechanically developed power minus losses. So I can keep this is mechanically developed power minus mechanical losses that is given in your question. Now suppose in your examination, if mechanical losses are not given, then treat this value as 0. In that case, you can directly say shaft power will become equal to the value of mechanically developed power. Directly I can say this will be your output power. And one more thing is, if the people are neglecting the stator losses, if the stator loss is neglected, then input power will become directly equal to air gap power. So under this condition, read your question carefully. If they are neglecting these constant losses and the stator losses, then input power, air gap power both are equal, and shaft power, output power both are equal. At this situation, what can be the expected efficiency of the machine? Now I'm removing all these terms now. Now what I'm going to do is I'm just calculating the efficiency of the machine. We know the formula to calculate the efficiency. Output power divided by input power. From the power balance equation, you can apply all the condition. But I am writing this formula here especially when I am not considering the stator loss. I am neglecting stator losses plus mechanical losses. Under this situation, if I am neglecting this two, what will happen is output power will be equal to mechanically developed power and the input power will be equal to air gap power into 100. From this I can say mechanical power equal to, we know, 1 minus S times of air gap power. That things we saw in the last class. So from this I can say air gap power will get cancelled. Directly efficiency can be written as 1 minus slip times of 100 in percentage. Understood? This is the formula to calculate the efficiency of the induction motor when the moment the stator and mechanical losses are being neglected. Got it? That's all. Let us continue from this. Now we are about to enter into the approximate torque equation. See, already what we saw is we understood the power balance equation, entire power equations we saw now. Now suppose if you are willing to calculate the air gap, sorry, if you are willing to calculate the amount of torque that will be developed in the machine, what can we do is this torque power, this torque can be calculated in two ways. One is you can calculate this torque with the help of mechanically developed power we saw just now, that is the mechanically developed power into mechanical speed of the machine. Mechanical speed means rotor speed. Or you can also calculate this power. See, this is from this you can calculate. Once again, what I did is I directly did some blinder mistake. See, mechanical power. Mechanical power equal to, what is the formula? In terms of mechanical parameter, this can be written as mechanical speed, that is called rotor speed, into mechanically developed torque. I can call it as mechanically developed torque. Of course, we can call it as electromagnetic torque. So this torque can be calculated from this. I can say this can be calculated with the help of mechanically developed power divided by rotor speed omega r. From this, what we know is just now we saw this mechanical power can be written as 1 minus g s times of air gap power. So this mechanical power can be written as 1 minus S times of air gap power. Just to write down. So this can be written as 1 minus S times of air gap power Pg divided by, what I can say is this omega R. We know omega R is the rotor speed. It can be replaced by 1 minus S times of omega S, that is synchronous speed. So if I am substituting that, so it will become 1 minus S times of omega S. 1 by S will get cancelled. From this I can say directly we can also explore this value with the help of air gap power divided by omega S. So this electromagnetic torque can be explored in two ways. Either the first one is if mechanically developed power and rotor speed is given, then also you can explore. Or else if you know the value of air gap power and synchronous speed, then also you can explore. Now substitute all the values. the approximate torque equivalent after neglecting all the stator parameter and the magnetizing core at all, the final approximate torque equation will become 1 divided by 2 pi ns by 60. This is for omega ns, that is synchronous speed, into 3 times of E2 square. This will be approximately equal to supply voltage. You can replace this E2 by supply voltage Vs or V1, whatever. So this E2 can be approximately equal to supply voltage. So this can be written as supply voltage square into R2 by S divided by R2 by S whole square plus X2 square. So this is the approximate equivalent equation for torque. Okay, that is very important because you can see almost 95% of the torque equation directly can be solved with the help of this. If you observe any equations in your examination from torque, definitely that would have been solved from this equation only. So in induction machine, we are doing so many approximations. So let us bring one by one. From this equation, I have told you that the value of supply voltage, the value of rotor induced voltage and the supply voltage Vs are almost going to be equal to each other. Now, if I want to bring the exact relation, what I can say is this induced voltage E2 almost will become equal to zero point 0.9 times of supply voltage Vn. So from that relation, what I can say is this torque is directly proportional to E2 square. From this equation, just to see. If you observe the previous one, see there. Torque equation is directly proportional to voltage square or not? Yes. If all other parameters are constant, then I can say value of torque is directly proportional to rotor voltage square, or I can say approximately equal to zero point 0.9 times of V1 square. Whatever the relation that I am giving here, try to note it properly, because while solving the problems, if you are aware of these all things, directly you can solve the problem. Whether you are whether you have studied all these concepts in depthly or not, it doesn't matter. If you remember these relations, you will be able to solve almost 95% of the questions. Now from the torque equation, at a low slip, suppose if the value of slip is very low, if the value of slip is very low, under this situation, what I can say is from the torque equation, we can bring the relation. We can neglect some parameter. At a low slip region, torque is directly proportional to S times of V1 square into R2. Just to do remember this. In the examination, at a low slip region will be given, or some data will be given to calculate the value of slip. Now you can identify if the value of slip is very less, if it is close to 0, or it is equal to 0 0.02, 0 0.004, 0 0.006. When the value of slip is very less, then the relation between torque and other parameter, torque will become directly proportional to slip V1 square divided by R2. All other parameters are negotiated at a low slip region. So from this you can observe that, see there, already we know torque is directly proportional to V square. At a low slip region, torque is directly proportional to slip. This region is called linear region. Why? Because here slip can be directly related with the speed of the induction motor. Slip can be directly related to the speed of the induction motor. So at a low slip region, since torque and slip will become directly proportional to each other, so if I am trying to draw the waveform between them, they will give you linear relation. If I am trying to draw the waveform between, if I am drawing the slip versus torque, what you'll be getting is almost you'll be getting the linear relation between them. So you'll be getting a straight line, approximately straight line. Remember, approximately straight line. In practice, you will not get straight line. There is a small droop in the curve. So approximately I can say it will become a straight line. But when it is happened, only at the value of low slip. Remember this. That is one case. Yes, I can say this. And you can also say in place of slip, you can also put speed. So speed versus torque will become linear, or almost they will become a slope, that is a straight line, or I can call it as linear when the value of slope is low slip region. Second case is if I am going with the high slip region, when the value of slip value will become high, then the relation, all other parameters are negotiated from the torque equation, then the torque will become directly proportional to, as usual, it will be directly proportional to square times of voltage, and it will be directly proportional to rotor resistance, but it is inversely proportional to square times of rotor reactance into slip S. From this relation, I can say torque and slip are going to be inversely proportional to each other when the value of slip will be very high. So what I can say is, if you draw the waveform between the slip and torque at a high slip region, suppose initially torque will be linear, when the value of slip will be after achieving some maximum value, further if I am increasing the value of slip, then the curve will become almost hyperparabola. So this region is called unstable region. We are calling it as unstable region, and this is going to be stable region. Okay, because it's a linear relation. Speed versus torque will be linear here. Either you can consider speed versus torque, or you can consider slip versus torque. But what I can say is this point is called maximum slip. So between 0 to maximum, you will be having the stable region. After a certain period, your system, our machine will be entering into unstable region. Still you are trying to increase the value of slip is more. So at the high slip region, obviously I can say that the system will become what? It is producing almost, the waveform will become rectangular hyperbola. The relation between torque and slip will be producing rectangular hyperbola, and the relation will become unstable. The stability of the system will become unstable. And you can also say that from the graph, whenever you are comparing the maximum torque with the load torque, if the value of load torque is greater than, see, this is electromagnetic torque. So while calculating the maximum torque, if the value of the load torque is greater than the value of maximum electromagnetic torque, then it means that we are in unstable operation. Your system is not stable. So suppose if the value of load torque is less than the value of electromagnetic torque, maximum electromagnetic torque, I can say our system is being operated under the stable region. I hope you all know this. Just to make a hint. If you are not aware of it, just to learn it. Again, once again, taking that approximate torque equation, here I am just replacing E by V1 square. So from this torque equation, let us see at the time of, if the machine, if you are requested to calculate the value of stalling torque or maximum torque or full load torque or breakdown torque, how to calculate that? Let us see the formula. The formula to calculate the maximum torque, that will be equal to 180 by 2 pi ns into V1 square divided by twice of x2 dash. See, x2 dash means, that is, x2 is the rotor resistance. If I am putting dash, it means I am referring the rotor resistance referred to stator. I have just transferred the rotor reactance to the stator side. It is transferred from rotor side. From rotor side, it is shifted to the stator side. That's why we are calling it as x2 dash. That's all. And the next thing is, this maximum torque can also be called pull out torque. It is also called stalling torque. It's also called breakdown torque. So in your examination, sometimes just to confuse you, they will be using the other names. So just to remember, for all these terms, breakdown, maximum, full load, starring, there is only one and only formula is 180 by 2 pi ns into v1 square divided by 2 pi x2. Now from this observation, you can observe, if you are observing this parameter equally, that is carefully, I can say, see that maximum torque is directly proportional to square times of supply voltage divided by 2 times of reactance x2 or x2 dash. Don't be taking care of this x2 dash or x2 at all, because in your examination you no need to do this calculation. You no need to transfer the reactant from rotor to stator, and that things that are not required. Directly value will be given and you can just play with this. Okay, don't forget, this is very important. Next thing is, so now the question is, we have to calculate the slip value when the value of torque will become maximum. When torque will become, when it is approaching to its maximum value, what is the slip? Slip value will become approximately equal to rotor resistance divided by rotor reactance. Directly I can say. And the next thing is, now the question is, what is the formula to obtain the full load torque? When our induction motor will be operated at a full load torque, then the formula will become as usual. Wherever same formula you can take 180 by 2 pi ns into v1 square into r2 dash by s divided by r2 dash by s whole square plus x2 dash square. If you observe in this formula, the only change is, in place of slip we are putting SFL. What is this? That is slip offered by the induction motor at a full load. That data you have to gather from the question. Then you can substitute it here. You can explore the value of torque developed by the induction motor at a full load slip. Next one is starting torque. If you are requested to calculate the starting torque, we all know at the time of starting, the value of rotor speed will be 0. Only synchronous speed will be existing. So the value of slip will become ns minus nr by ns. Since the value of nr will be 0, so I can say ns will get cancelled and the value of slip will become 1 when the moment we are starting the induction motor. So what I can say is, take the same torque equation, replace wherever you have s. For slip you have to replace 1. Then the starting equation will become 180 by 2 pi ns into v1 square into r2 dash divided by r2 dash square plus x2 dash square. Slip is missing. Why? Because slip will become 1. It is not missing. It is here only, but that value is 1. We are not considering it. Okay. Now let us continue. Question is, If we are taking the ratio between starting torque to maximum torque, then what will happen? The formula is, if you already I have given starting torque and maximum torque, you please calculate this. If you are taking the ratio between that, then what you will be getting is twice of, yes, that is slip at maximum torque divided by slip at maximum torque whole square plus 1. So this is the formula to bring the ratio between starting torque and maximum torque. So in your examination, you will be requested to see that what they will give is, in the examination they will give you the value of rotor resistance, they will give you the value of rotor reactance, and you will be requested to find the ratio between starting torque and maximum torque. Sometimes they will also ask you to calculate the ratio between maximum torque to starting torque. Be conscious with the question. If they are asking starting torque to maximum torque, then this is the formula. If they are asking maximum torque by starting torque, then you have to flip it just to take the reciprocal for this. Anyway, if R to X2 will be given, then how can I calculate the ratio between these two? We know, just now we saw at a maximum torque, what is the condition? We saw slip equal to R2 by X2. So if R2 X2 will be given, it is very easy for you to calculate the value of R2 by X2. Just to take the ratio between them, calculate the value of slip, substitute it into this equation, you will be getting the ratio between starting torque to maximum torque. The next question is, if you are requested to calculate the ratio between full load full load torque to maximum torque, then the formula will become 2 divided by maximum slip, that is torque at maximum slip at maximum torque divided by full load slip plus slip at full load torque divided by slip at maximum torque. That is the generalized formula to calculate the ratio between full load torque and maximum torque. Here I am giving one trick. Remember, what you have to do is, you do one thing, just keep any torque in the numerator, divided by, in the denominator you can keep the maximum torque, equal to, what you have to do is just to keep 2 here, and in the denominator you can write torque at slip at maximum torque divided by s plus s divided by maximum torque. See, you don't need to memorize this. Very simple. Here, S max divided by S plus S by S max. After writing this S is the generalized slip for the generalized torque. In your examination, if they are putting starting torque here, if they are asking the ratio between starting torque to maximum torque, you know at the starting torque, slip will become 1. So for this generalized slip, you can put 1. If they are talking about the ratio between full load torque divided by maximum torque, then what you can put, then this slip in place of S you can put SFL, that is full load slip you can put. What you can put is, you can put full load slip. That's all. So that is how we are going to take the ratio between torque versus maximum torque. Understood? Any torque. So here we are taking starting torque to maximum torque, full load torque to maximum torque, whatever it is. So just to remember this generalized expression. After that, now let us enter. What we are going to do is, we are going to enter in our slipping induction motor, by varying the value of voltage and frequency, we can control the speed of the machine. So now the question is, in general, from the torque equation I can say torque will become anyway, induction machine is going to be operated at a stable region. First conclusion, what we saw is, if torque and slip are directly proportional, then the machine will be operated at a stable region. If the torque and slip are become inversely proportional, then the machine will be enter into unstable region. Now you please tell me, in which region you would like to operate your machine? Sir, what is this question? We are always like to operate our machine in the stable region. So in case of stable region means we are going to operate our machine at a low slip region. At a low slip region, I can say induction motor is stable, and the relation between the torque and other parameter will become, torque is approximately equal to slip into V square by frequency of. Now the question is, what is the value of starting torque? What is the relation between starting torque versus voltage and frequency when the moment we are varying the voltage and frequency? When the moment they are varying the voltage and frequency, remember these questions, because the data will be given in your examination. Voltage rating will be given. First they will give some voltage for supply voltage, and they will give some voltage in the second case. They will give frequency in the first case. They will give some other frequency in the second case. First case they will give the torque. In the second case you will be requested to calculate the value of torque. So what you have to do is, just to go ahead. When the moment they are varying the voltage and the frequency both, then the relation between starting torque and frequency will become, starting torque will become directly proportional to square times of voltage divided by frequency, F into F. See, actually what will happen here is, we will be getting V by F square. Wait, I will be writing it here. So here I wrote one by one. See that when the moment we are writing the relation between variable voltage and variable frequency, the relation will become starting torque is directly proportional to square times of voltage divided by square times of frequency. If you are multiplying this, it will become f square. So you can put v by f whole square. Starting torque is directly proportional to v by f whole square when we are varying both voltage and frequency. Second case, suppose if the value of v by f ratio is constant. If they are maintaining the value of V by F ratio is constant, then what will happen? See that here we have the V by F ratio. If the value of V and F both should be maintained as constant, then what you will be getting is starting torque will become directly proportional to F only. Suppose if they are maintaining the value of V is constant, then if they are varying the value of only frequency, then what I can say is if they are maintaining the value of V is constant, then the starting torque will become directly proportional to 1 by F cube. Actually, 1 second, I think there is some mistake. Wait. In the denominator, we have synchronous speed and reactance. 2 times of frequency will come. Yes, it will be square. Actually, here you have to put square. When V and F both are varying, what I can say is it will become V square divided by F cube. That is a mistake. Please correct it. Okay, that's all. Let us continue. So when we are varying both voltage and frequency, what I can say is the relation starting torque will become directly proportional to V square by F cube. Second thing, if V by F ratio is maintained as constant, see that just now we saw starting torque is directly proportional to V by F whole square into 1 by F. If V by F ratio is constant, then only the starting torque will become directly proportional to 1 by F. That's a mistake, technical error, just to correct it. Then this relation is correct. Suppose if I am maintaining the value of V is constant, then what will happen? Then starting torque will become directly proportional to, as we said, V is constant, then in the denominator we have F cube. So it will become inversely proportional to F cube. All the relations are very important. You can observe there are so many direct questions from the speed control by keeping this type of modulations. After that, what they are doing is now they are changing the voltage and the frequency will be maintained as constant. What we saw, starting torque is directly proportional to V by F whole square into 1 by F. When I am maintaining frequency is constant, then the torque will become directly proportional to V square. So you can observe all type of questions are there in your examination. All type of questions are there in your examination. So it is very important to keep whatever the relations that I am giving here, try to keep everything in your mind. Okay, now you can see some clumsy waveform here. Nothing is there. I have already given everything. So when the value of slip is very low, we are going to operate our induction machine. I would like to operate my machine only at a low slip region. I told that. If you carefully observe, see there. I am just rounding it. This is slip equal to 0 and this is the maximum slip. And after that, we are still if I am trying to increase the value of slip, then slip will be reaching 1. In case of motoring mode, for your induction motor, if the value of slip is lies in between 0 to 1, then the mode of the machine is called motoring mode. In the motoring mode, we have a certain region. If the value of slip is lies between 0 to some amount of low value, that is called low slip region. In low slip region, your system will be stable. It's better I will draw somewhere. See there. I have x-axis, y and x-axis here. At a low slip region, we are starting here. Slip is 0. The relation between torque versus slip will become linear. They will be linear. They will be linear up to certain point. So the relation almost will become linear. So I can say this region is called stable region. And if you are continuously increasing the value of slip up to this point, somewhere here your machine will be approaching its full load. We can operate the motor at a full load at a low slip region. This region is also called linear region and this is the perfect suitable region for us. And after this point, this is the point where your torque will become maximum. See there, actually at this point, this is the slip at which torque will be approaching to maximum point. Further, if you are increasing the slip, already we were achieved the maximum torque from the y-axis. Already we were achieved the maximum torque. Further, if you are trying to increase the value of slip, as we saw at a low slip region, slip and torque both are directly proportional. So with the help of this relation, I can achieve the maximum torque. But after this point, what will happen is, further if you are trying to increase the value of slip, at a high slip region, both these people will become inversely proportional to each other. Then we saw that, we observed that this will become rectangular hyperbola. This region is called unstable region. Torque is continuously decreasing as I am keep on increasing the value of slip. So this is not the preferable choice for me. Anyway, still your motor is being operated as a motor under this region. Under this region, between slip s equal to 0 to 1, I can operate my motor into as a motor. It will be operated as a what motor. After that, still if you are increasing the value of slip beyond 1, when the value of slip is crossing 1, if it is goes to greater than 1, the region of the motor will become converted into the braking mode. So when the value of slip will become greater than 1, then the mode of operation is called braking mode, right? Do remember, some types of direct question is there in your examination. See there, this region is called unstable region, this region is called stable region. You must remember this. There are some direct questions in your examination. So if you remember whatever the things that I'm giving in this, if you understood everything, I'm saying that without studying your subject, almost 70 to 80% of the question you can directly solve. Okay, fine, sir. Now suppose, see there, at s equal to 0, before s equal to 0, I can say s is less than 0. Before s equal to 0 means slip value will be negative. When the slip is negative, then the mode of the operation is called generative mode. Already we saw that. So this is what I have completely represented in our previous waveform here. If a slip is lies between 0 to 1, then I can say the motor of, then the operation of the machine is motoring mode. And if slip is greater than 1, then the sorry, when then the mode of the operation will become braking mode. When the value of slip is less than 0, then the mode of the operation will become, see there, I have highlighted here, that is called generating mode. Okay, in motoring mode itself, at low slip, motor will be stable, at a high slip motor will become unstable. That's all. Now after that, in case of induction motor, approximate formula to calculate the efficiency when slip is given. Guys, I have already given one more formula for slip, that is approximately equal to 1 minus s. You can use this formula. When you will use this? When we are neglecting the stator losses plus mechanical losses. Not everywhere. This is the approximate formula to calculate the slip versus efficiency at all cases. Okay, just you can note it down. If nothing will be given, only some slip is given and some other relation losses are given. If you are unable to calculate the efficiency, just to try to use this formula and cross check whether it is giving the option or not. If it is there, then of course you can go ahead with that. Okay. So this is all for this lecture. Almost I have completed the entire concepts of the induction motor. I haven't left even a single point of the three-phase induction motor. Okay. So if you haven't watched the previous lectures, please go through once, because almost I have covered all the concepts that are required for synchronous machine, and I have covered all the concepts that are required for transformer. Now I have completed all the concepts that are required for three-phase induction machine also. What is the left portion now? Apart from this, we have DC machine and plus single phase induction machine. So these things we'll be covering in the upcoming lectures. Anyway, fix this time. Hereafter we are going to be live only at the time of after 9 o'clock. It may be 9:15 or 9:30. Between this we will start the live class. Then we will continue from here. We will be taking the classes maximum 1 hour. Minimum we will be completing 30 minutes. Maximum based on the content that we are delivering on that particular day, it will go up to 1 hour. So first we will try to complete the electrical machines. After that we will plan for other subject if time permits us. Okay, but this lecture is worth, you can trust me. If you are not aware it, just if you are not studied the electrical machine, just to go through the entire concept that I am giving here. After that, if you try to solve the problem, I am giving 100% surety, you will be able to solve at least minimum 70% of the questions. Okay, to get the further updates every day, if you want to know what's going on and what will be the updates in our classes and timing, if classes will get postponed, to know all this data, just to join in our Telegram group. You can join in our Telegram group by observing the link. It may be there in the description box. If it is not there, just to visit our website www.rkelectricalgrid.com, rkelectricalgrid.com. From there you can get the link for Telegram, WhatsApp. So if you want to connect us, you can directly connect through WhatsApp and you can ask your queries. If you want to join with us in Telegram to know about the future exams and updates, class updates, you can also join in our Telegram group directly. Okay, so this is all for this lecture. To know the upcoming dates, see, I just wanted to ask you all, one small request is try to share it with all your friends as maximum as possible. I'm just trying to do something here. If you are utilizing it effectively, everyone will get the benefit. Some of you might be going for job and somewhere, if you are unable to get the idea how to get the short notes and how to study shortly, there is possibilities there. Instead of completely spending 7 or 8 months in the entire subject, alternative way is spending very few months learning all the concept quickly, directly. Just you can learn it directly, which are required only for the examination. Once you clear the exam, then you can study detailedly. That is the second stage. Our primary stage is, if you want to clear the exam, you can also learn it quickly. So to learn that quickly, you need some referral. It may be some faculty guidance, or maybe some notes. So if you are going in that way also, you can crack the exam. In that case, I will be there to help you. Okay.